Welcome to Dave and Dharm Demystify, a FinTech Futures podcast, helping make sense of the world of FinTech and digital finance. Please sit back and listen as the two Ds take a subject and discuss it to make it clearer and easier to understand.
Demystify.
Welcome everybody to the Dave and Dharm Demystify show. And this week we're going to demystify legacy modernization. This, as you all know, is one of my hot topics. So I'm really looking forward to this conversation. And we have a special expert here, Irene Sandler. Hi, Irene.
Hello. How are you?
We're all good. Thank you. Thank you. Would you, in our honorary tradition, just give us a little bit of an intro to yourself, your background, and who you work for?
Sure. As Don said, I'm Irene Sandler. I'm the Chief Marketing Officer for Mechanical Orchard, a startup that's about 2 years old. My background, though, comes from a mix of both startups and corporates. I spent most recently almost 10 years at Cognizant Technology Solutions, a massive system integrator, a global system integrator. And before that was also nearly 10 years at Cisco, where I managed a lot of different products. And by the end of it, led product marketing for the Internet of Things group. And prior to that, I did a handful of startups, some of which were successful, many of which weren't. But it's nice to be back in the startup world after a 20-year corporate detour.
Yeah, well, I mean, Dave and I are well accustomed to switching from corporate to startup world. So well done. But I guess the thing that caught my attention straight away is Mechanical Orchard. What a name. What does the company do? I mean, and how did it get the name, more importantly?
Okay, maybe I'll start there. So the name came out of this idea of how do we apply intelligent automation with AI, of course, to this very mature, intractable theming problem of legacy modernization. But one thing that we definitely knew we had to do is to apply more of an anthropological lens on the issue. I think most approaches kind of look at the code first and say, hey, we've got to turn this old code into modern code. And our realization, which is at the foundation of the company, is that it's actually very, very multidimensional. Without going too deeply into theory, there is something called Socio-Technical system design. And as legacy systems were created, they have become encrusted with some of the social and the organizational processes that are part of it. So when we were thinking of a name, obviously the automation part came to the word mechanical, kind of vestiges of Mechanical Turk. And then the orchard part came out of this idea of it being very organic and nurturing the growth of these systems in a very ordered and productive way. It also happened that Orchard is the middle name of our founder, Rob Mee's mother. So she had a middle name of Orchard, and when that word came up, bing, kismet.
Fantastic.
Amazing. I'm really fascinated by the socio-technological philosophy. It's so interesting because I guess with Dharmish, we've worked with banks over many years. And one of the conclusions I've reached is actually, it sort of seems like a lot of banks kind of almost hard code their cultures into their technology. Is that kind of what you're talking about in terms of the sort of socio-technological philosophy?
Yes, in part, absolutely. So culture gets encoded, right, into the way systems work. We, somewhere along the way, got a very narrow view of what technology is supposed to do, right? A very, dare I say, kind of engineering-centric view. And I think when you look at an organization, it's in the name. It's an organism, and it's got a lot of culture, it's got a lot of norms, it's got a lot of unspoken ways of doing things that then get embedded into the systems. So when we talk about socio-technical design, we're looking at the users, of course, the people who are the stakeholders, the board, and there's a whole variety of different incentives and desired outcomes with all of these different groups. And so there has to be a conscious effort in going across them. Now, we're not consultants. We don't do that part, but what we do is take into account the fact that these are very complex systems that have reified these cultures, exactly as you say, Dave. And therefore, they can't be viewed through a lens of code alone. They can't even be viewed through a lens of technology alone.
Just on that, I kind of struggle with, like, how do you codify a culture, right? But I do remember when I first started mainframe programming, we had this kind of attitude of build to spec, which was, I would kind of look at a problem and say, right, okay, I can do it this way. But if I add these things to it, which is additional time and effort, then we'll have some flexibility in case you change your mind later on, or we've got new file systems, etc. Whatever it was, adding some flexibility to the solution so that we didn't have to make changes later. But the mentality, I guess, or the culture was very much like, we need to get this system out. We've got a finite budget. If this flexibility is for other departments, I don't really care. I just need to get my bit done. I've got my budget. I'm not paying for other people. It was those kinds of things that led to kind of inflexible solutions. Yes, of course, the technology itself had some limitations. We don't have all of the things that we have in Java and other modern languages. But do you mean stuff like that where you just build a spec, or, you just build without the flexibility because you want to try and get something out sooner?
Yeah, so let me state up front that legacy systems, by and large, especially mainframes, are incredibly robust. They're running, they're working, they're doing the hard work of making sure, manifesting the business process, the actual business. And in fact, the more critical the system, the more it encodes the competitive advantage, I believe, of an organization. So I want to state up front that we don't have anything against mainframes or legacy systems. They're working. I think the challenge is exactly what you talked about in the beginning around optionality. But when you put in optionality for a limited number of, or for a particular function, or if you're trying to answer a problem or create a solution for a problem for a specific stakeholder, then after a while, all these kind of individual solutions to individual problems start to conflict, and they create this spaghetti code, the spaghetti system of a legacy system, so that future changes become more difficult. So there's no deliberate effort in making these systems complex. It is just the natural outgrowth. What's different now is that we see that there's a way to kind of get through that.
No, I totally agree. I think if we knew everything that was about to happen in the next 5 years, we'd have designed for it. But quite often we just don't. But I guess one thing that I would say is that I have a VHS player. It works, but I don't use it because actually the modern way of streaming on demand is just so much more convenient, so much more flexible, cheaper, better, faster, etc. And there may be nothing wrong with those systems as they were for the purpose they were designed. But I would argue for the modern world, when we want things to be much more scalable, we want to make faster, cheaper updates, things have to change somehow.
Absolutely.
Right?
Yeah, it's about applying optionality, not just to that particular feature that you're working on, but to the entire system as a whole, to the entire organization as a whole.
But it seems like this whole topic of modernization, I guess the industry, like particularly banking, people are looking at the latest options around, in a way, how they create a lot more flexibility on these platforms. I guess that's the bottom line, because it sort of feels like we're heading into a world of unknown unknowns, really. And those unknown unknowns sort of seem to be coming at us faster than we can kind of deal with them. And having inflexibility in terms of a platform, I think, is a real problem for large organizations. But equally, they must be balancing up the risk of making wholesale changes. So I'm kind of interested in the approach that you're taking around that modernization.
Yes. The prevailing paradigm of legacy modernization, I think, is one that has been around so long, the last 20, 30 years, that it's become a given, even despite the fact that failure rates for modernization projects range, depending on which survey you read, between 50 and 70, 75+%. Right? So we've gotten used to knowing that things will be a failure. So Dave, you talk about risk, and that's exactly what I think is driving a lot of hesitancy around modernization. If you think about it, there are very long processes, 5-7 years. Your champion or your executive champion may not even be around. The average tenure of a CIO is 3-4 years. And so when you look at it from a personal lens, it does make it seem like, why would I want to take this on? It's high risk, low reward in a way. Everyone's going to be yelling at me. So the interesting thing is that though we've always done it this way, is something that's ingrained. So I think first and foremost, there's a mindset change. So when there's a technology as potentially profoundly game-changing as AI, it's a nice opportunity to look at this very entrenched problem where people kind of have, I don't want to say lost hope, but there's this kind of assumption of high risk, and rethink it from first principles. It's sort of like when cellular became available and you had these vast places in Africa that didn't even have landlines, and they still don't have landlines. They didn't need landlines. They could kind of hop right over to mobile. And similarly, I think applying AI and thinking, okay, this powerful technology, how can it be applied to the problem of legacy modernization? And how can it maybe loosen some of these assumptions that have gone into modernization? That's kind of what we're looking at. So we're thinking of how do we modernize these monolithic, very complex, interdependent, integrated spaghetti code of systems with AI through the lens of AI. So taking that kind of top-down approach rather than kind of a bottoms-up approach, which is the bottoms-up approach being, okay, how can I minimize changes to my infrastructure? And then how do we de-risk? So our primary value proposition is one of de-risking. And we do that in two primary ways. One, we really try to comprehend the system. And here's where, of course, AI tooling is not unusual now to see it coming through to help comprehend a particular system. You can download all the existing code, for example, into a large language model and ask it questions. What does this workload do? What does this component do? Which are the databases that are hit by this particular workflow? So those are some of the comprehension. We get a better sense of what's going on. So tools are out there that can do that. Then, though, there are an additional number of steps. The primary way that we reduce risk is that we build a replica of the system behavior. So we don't go straight to the code and transpile it and turn it from COBOL to Java, or what some people call JOBOL, because once what you have then is something that's equally incomprehensible as the original COBOL, right? So instead, we look at the behaviors. We look at the data flows that go in and out, and we try to construct a model of the behavior and then replicate that in completely modern code. And once we do that, we do that for a single component first. We do that iteratively. So that's the second part of reducing risk, so that we can take this particular component all the way into production. It is running in parallel with the existing legacy system. And as a result, it goes through these serious equivalency checks to make sure that both functionally and from a performance standpoint, it's performing exactly from a behavioral standpoint as the old component. And then when it meets all those checks, then we cut over just that piece into a cloud-based environment or a private cloud or whatever new environment that we're looking for. And then we take the next piece and do the same thing. Now, this is not a completely new concept. I think in the past, it's been incredibly slow. So to your point, things changed so quickly, it wasn't really possible to go, spelunking through the old code, figure out what everything's doing, because by the time you figure it out, everything's changed. And gosh, we also need to start innovating on it. So why don't we just try to do everything all at once? And that leads to failure modes. So when you take it, though, and apply AI, you're able to do it a little bit faster. So the first workload might take some time because we're figuring out what's going on. We're setting up that parallel environment, or with VPNs and making sure, DevSecOps is all set. We've also, from a behavioral standpoint, have to talk to all those teams, right? We have to talk to the infrastructure team. We have to talk to the users. We're trying to get a very full picture of the behavior of that particular component, how the users are using it, what's absolutely sacrosanct, what's going to cause the most disruption. And because we're only replicating the current behavior, the disruption is also minimized. So we reduce the risk on two fronts: to the disruption, right? Business processes remain intact, but also to the actual technology side of moving things over. And each component moves faster and faster because we learn more and we're able to apply more automation through AI tooling to make that faster.
I like this because I think in a lot of digital transformation, people are looking for a change. They're looking almost actually for the business change. And there's a lot of banks out there that don't feel like they need to change because they're going to do the same thing. They might want some variations in the product maybe, but they're not in a rush to get them out, etc. So they don't feel like they have to change. Whereas actually what this does is allow you to at least get off the legacy technology gradually, right, with a lower risk, but also maintain the current state before you start to realize that you do need to change your business as well. But so, I mean, I kind of like that, but can you tell us any more about like, how do you work with the AI? How much human involvement is coming from your team? And then how much is like pure AI and the model that you've created?
Yes. So it's very fluid as we build this out. We have 6 steps in the process of modernization. And I would emphasize this is still very much a professional services type of engagement. We don't have a magic tool. I don't think there will be one for some time. I could be wrong, but I don't think there's a magic tool out there yet for this very complex interdependent problem.
You just don't press the button to say modernize and it goes
There's
off.
no easy button. But that said, there's a huge yawning chasm between a silver bullet, easy button, and the way things are now, right? So we're looking at 70% failure rates. There's a nice big gap there that is populable right now and that we can address. And so in each of our 6 steps, whether it's first kind of understanding the system, analyzing the system, building that replica, driving equivalence, right, making sure that it's equivalent, and then putting stuff into production, we are looking at ways of accelerating that through AI. So the obvious ones are in comprehension. And there are some non-AI tools as well, right? Extracting data, extracting code, it doesn't involve AI. It's just FTP, basically, or a version of FTP. But what we do is then have some tools that we're developing. And the nice thing is that because we do these professional services, we have a really tight feedback loop, right? We can test our tools in live situations and continually refine them very quickly. So each of these steps, we have a set of tools that we're working through in the hopes that in some point in the future, they all come together kind of as a platform. So our founder, of course, is Rob Mee. He was a founder of Pivotal Labs, which then through a number of different iterations became part of VMware and created a Cloud Foundry, which is also a platform. And so we have a similar play there where we were looking at specific discrete tools to build Cloud Foundry that then was aggregated into one platform.
Are you able to sort of give us an example of this sort of happening for a client and, some of the benefits that particular client might be seeing?
Sure. Yeah, I'll give the example of actually our very first client. It's a huge retailer in the US, in the Fortune 500. It's quite old. A lot of its systems are over 25, 30 years old. Their main system is an inventory system still on a mainframe. And of course, the performance of the company, of this retailer, has been lagging behind its peers because it's not been able to move quickly enough. So they asked us to help with modernizing their inventory system. 10 million lines of COBOL, very monolithic. It was something that had been attempted several times before, tens of millions of dollars spent, and 0 success. So all of those projects, I believe there were at least 2 projects before they, almost in desperation, called us and said, can you help? And so we have been working with that company for about a year and a half, almost 2 years now. And we've successfully moved over their first most critical app that they wanted us to address, their highest risk app. It's also a global inventory system that manages SKUs. And from the beginning to the end, inclusive of interviewing all the users, working with the infrastructure and operations teams, it took us, I believe, less than 9 months to get that into production, and it's running in production.
Wow.
And so in that particular case, that particular application of the mainframe was about 15,000 lines of COBOL. And we shrunk the lines of code down considerably. But more importantly, when we went for site visits, because part of socio-technical design is to make sure the engineers are very much close with the actual business users, the users were delighted. And I'll tell you why. Not only did they not have to change any of their processes, so we had to modernize, let's say, the kick screens, those green screens, right, where you press F4 for the main menu. We didn't have to change any of that. They could still press F4 for the main menu. But it turned out that because it was off those green screens and in an HTML-based interface, it looked exactly the same. But they were like, wow, we can put this on a web browser. We can put this on a mobile. We can resize the window. There was a lot of talk about resizing the window and how joyful that was, right? We can resize the window. And so even though behaviorally, we're not demanding any changes of the people at the front lines working on this system, just the mere fact of putting it into a modern code base was a cause, and this was unexpected for us, a cause of delight on the business user's end. So that was really gratifying because even though we kept the business processes completely the same, nobody had to learn anything new, they were still delighted by this seemingly very small change. And now, Dharmesh, to your point, they can go much faster and introduce all sorts of changes and innovations.
So can I ask, I mean, that's a great example where you've basically replicated the interface, but say there was then the opportunity to change that interface into something more modern, like CSS and HTML or something like that. So that change could then happen much faster, is what you're saying.
Exactly.
Because of the fact that it's in modern code, rather than having to go through the whole sort of traditional process of modernization. So it's sort of ready to be modernized is...
Exactly. So Kent Beck is our chief scientist. He was one of the original signers of the Agile Manifesto, kind of fun fact there. But he has a saying that I quite like, which is first make the change easy and then make the easy change.
Wow.
But first making the change easy is really, really hard. So
it's a really interesting and important point because I think Dharmesh kind of mentioned it before that if you're going to make big changes, you have to change the culture at some level, but changing the platform and the culture at the same time is a really difficult thing to do because of the way businesses are set up. So actually having a equivalent platform, which is much more flexible, gives you then the opportunity to change the culture and then reflect that in the platform. So it's a really interesting way of approaching it, I think.
We think so.
I think from what I've heard, the really smart part about this really was if you had 15 million lines of code, you change 15,000, that's 0.01%. How did you find that 15%? That's the clever part, right? It's finding that. It's not like, well, we're trying to swallow an elephant here. It's like, how do I get to the Achilles heel that's been holding back, that will have the biggest impact for the smallest change? Is that where the AI kind of comes in?
The AI helps. So there's kind of three things that go into what we call finding the seams, right? You've got this monolithic application, or even just a complex one, not even necessarily monolithic. So there's three things that we do. One is to first inventory all the major things from a business outcome perspective. What are you actually trying to do? And then mapping that back to the applications that support those business processes. And then working very closely with the client on what's the highest risk component here. So there's this kind of institutional knowledge that we're trying to extract from the organization to help us understand where is the biggest pain point. And we usually try to go for the biggest pain point first, right? Because if we can de-risk that, the rest of it is easy. If we can get that most riskiest or top 5 most riskiest apps into production and show that it's working, that does a lot of things. First of all, it boosts confidence that this whole thing actually can be moved off in its entirety. That's a huge thing. And I think that's undervalued a lot, this idea of confidence, because people go into it holding their breath, thinking, okay, in 3-4 years, after I've, transpiled all the code, after I've done all the testing and integration, I'm going to press the on button and I'm going to hold my breath. This changes that. This says, okay, you've got one piece working and it's going great. So that's the primary thing we do. Identify the app and with the client, determine which are the priorities to pursue. The second thing is, you're right, applying some AI-based tooling to help visualize those interdependencies, right? So some actual visual graphs that you can kind of rotate and say, okay, some mem graphs, like, okay, we see that this database is being written to 3 times. This component is creating an email queue, right? And all these things, this thing sends a report every 24 hours at midnight to this particular set of emails. So once we have an understanding of that, and that is much faster to be. AI is making it much easier to map out those interdependencies and those data flows. Then we have kind of another piece of the puzzle to say, okay, should we attack this one? Because it's relatively discrete. It only has, only writes to 3 queues and not 74. And we pick one. So we, again, say, what are the riskiest? What are the ones that are relatively discrete so that we can start with a clean-ish type of component and write that into production? Then we go into the rewrite process. So the selection, as you point out, Dharmesh, is incredibly important to get that first one right, not only from a technology standpoint, but from a psychological standpoint.
Fantastic. We're running short on time, and you've just published a report, and I just was sort of keen to ask you about that report because I think people can download it. So could you just sort of give us a bit of a summary of what that report goes into?
Sure. It's related to this idea of confidence. We had a hypothesis that a lot of the times people know that they need to modernize. That's not in dispute, right? Things are changing quickly. We need to be able to adapt to the market, but they were hesitant. And our hypothesis was that they were hesitant because A, high failure rates, but also B, the sense of kind of the political considerations were stymieing this enthusiasm for legacy modernization, and back to kind of the socio-technical considerations, right? The sense was that the executive committee or the board, they were looking at budget and timeline, but not necessarily looking at the business outcomes that come at a very granular and almost popcorn way, right? We've got all these different stakeholders. The finance department wants to be able to do this. The marketing department wants to be able to do that. And when you abstract it too high, it becomes like, is it on time? Is it under budget? And so there was indeed a lot of fear. I think one of the key statistics that validated it is that 71% of our respondents, who are all senior executives in the IT departments of companies in the US and UK, 71% found legacy modernization stressful.
Right.
Another 54% actually delayed a modernization project because they felt like they couldn't get the right people on board.
Right. Wow.
Which is saying a lot, right? So there is a lack of confidence because there's a lack of proof points. Confidence comes from being able to prove that something is working and being successful. And the traditional ways that we've approached modernization haven't really been able to deliver that.
Fantastic. We'll put a link to the report in our post around this podcast. So thank you for that. And I must say that when I've been looking at kind of software development and AI, like the vast majority of people, in fact, you're probably the first outside of that camp, have been looking at brand new code standalone, which is, for me, an easier problem to solve. Yes, I know it's not that straightforward to get an AI to write code necessarily, but there are tons of people generating new platforms, brand new standalone platforms through AI, Microsoft included. But you seem to be the first that's kind of really tackling the real deep problem, the real hard problem, which is how do I take something that's already running in a legacy tech and then transform it to something new? So I'd like to say just congratulations on tackling something hard, but very necessary. And it looks like you've got the proof points in place to carry on doing that for lots of other people. So well done. And thank you for coming onto the show.
Yeah, it's been a pleasure.
Thank you for tuning in to Dave and Dharm Demystify. We hope you enjoyed the show. Don't forget to like and subscribe and tune in next time as we take another topic and demystify it.